5.1 Composite Functions. This entire section is completely review. You have been doing composite functions since Math 1, and you started seeing these functions in the form of maybe like f of 2. And if you had a function, let's say f of x was 3x squared plus 2x minus 7, you would plug 2 in for each x. That's a composite. You're composing a function based off of something. It's very similar to what we are going to be doing today. But today, instead of just plugging in a number, you might have another expression that you need to plug in, maybe an x plus 2 or something. And they're pretty straightforward functions, mostly linear. You're not going to be dealing with quadratics. So very, very easy day today. In Math 3, the notation that you did see for composite functions was in this form, f of g of x, where you would take the g of x and you would plug it into f. You will also see it in this course, in this notation, f. This little open circle means of g and then of x. So it's the same thing where you're going to take the g of x and plug it into f. So just be familiar with both of them. I will try to use both of them so you can start making that connection. On our quizzes and tests, you will need both of them anyways. So let's look at example 1. Now, I'm not going to rework every single example here. It should take maybe me going over 1 or 2 of them to kind of get your memory back on how to go through and evaluate compositions of functions. So I need you watching for this first example. This is a relatively easy example, but a frustrating example because there is no work for you to look at. So you really just need to follow what I'm going to be doing. So I'll probably just go ahead and do the first 3, A, B, and C. Actually, maybe I'll do, I'll go ahead and do A, and go ahead and do F, and I think I'll do D. Okay, you ready? So this says f of g of 1. So you can think of this as f of g of 1, which means you need to find g of 1 first. Since that is the inside, we work our way from the inside out. So g of 1, I go to my table. This is your x. The number inside the parentheses is x. So I go to where x is 1. Then I go to the part of the table that says g, and that is 0. Since f is on the outside, where I see g of 1, I am going to put 0. So I want f of 0. So now I'm going to go to where 0 is. So here's my 0. Since it's f of 0, I go to the f row, which is 5. So my final answer is 5. And this might be something where you need to rewind it and keep watching. When I go over this in class with you, it will maybe make more sense because you're going to see me physically going from one area to the next. In D, this is f of g of negative 2. So I'm going to start with g of negative 2. So I'm going to go to my table. Here's negative 2, and g is negative 3. So now f of negative 3. I go to negative 3. What is f? 11. That is my answer. Now I'm going to go to this next one. This is f of negative 3. So I'm going to start with the inside, which is f of negative 3. And f of negative 3, well, I just found out from D, f of negative 3 was 11. Well, now I want f of 11. What? My table just goes from negative 3 to 3. There is no 11. That means that value does not exist. I am only allowed to look at numbers from -3 to 3 to start. X can only be -3 to 3. So it doesn't exist in this situation. If I had a function as an equation, then yes, I would be able to evaluate that. But since I'm given a table, it is restricted into certain values, and it is what it is. Example 2. I'm only going to do, let's see, I think I'll go ahead and do B. So let me rewrite this. This is g of f of 2. So I start on the inside, which is f of 2. The f tells you you're going to use the f of x equation, and the 2 is what you put in for x. So this is 2 times 2, which is 4. Now, f of 2 equals 4. So where I go back here, and where I see f of 2, I put a 4. So g of 4 tells me I'm going to use the g of x equation, and where I see x, I put 4. 3 times 4 squared plus 1. 3 times 4, 16, sorry. 3 times 16 is 48 plus 1 is 49. That is your answer. The 4 is the process, part of the process in getting your answer, part of the work. But the 49 is your final answer. I need to pause the video for a second, you guys. Okay, I'm back. Now let's look at example 3. Find the domain of the composite function f of g. So this is saying f of g of x. This means I'm going to take g of x and I'm going to plug it into f's equation. So I'm going to take g of x, the 2 over x, and I am going to plug it into g of x where I see x. So this will be 3 over, and instead of x, I put 2 over x, and then I have the minus 1. Now it says find the domain of this function. We need to remember, when I have fractions, you cannot have 0 in the denominator. I have a note over here I would like you guys to pause and then write down. We need to remember, if we have a fraction, the denominator cannot equal 0. So you set the bottom equal to 0, solve for x. If I see a square root, the inside cannot be negative. So you set the inside equal or greater than or equal to 0, and then you solve for x. Everything else is going to be all reals, negative infinity to infinity. Again, if you need that, pause it, write it down. So the tricky part with this is there are actually 2 fractions. So I want you to take a second, and I want you to look at this, and I want you to try and figure out where are those 2 fractions. The first one I see, this is 3 over, well, there's one denominator. That's one of them, 3 over that whole thing. There is my denominator. One of my denominators is 2 over x minus 1, and I have to set that equal to 0. I need to solve for x, and I need to figure out what will not work. So I add 1, 2 over x equals 1, multiply by x, 2 equals 1x. So I know x equals 2. That gives 0. That means x cannot equal 0. But I need to remember there are 2 fractions here. My other fraction is 2 over x. There's my other denominator. So I need to set that equal to 0. Oh, that was easy. That one's done. So my domain, x such that x cannot equal this little fraction, x couldn't equal 0. The bigger fraction, x could not equal 2. There's my domain. Be careful for that, you guys. You do have a question like this on a quiz where you will have to compose functions and find the domain. Pay attention to if you have fractions or square roots. Everything else is all reals. Number 4, state the domain of the composite function. So more composite functions. So f of g, this is the same as f of g of x written this way. This is the same as g of f of x, f of x, and g of x. I'm only going to do one of these, and I'm going to go ahead and do d. So I'm going to write out two g of x's. G of x equals x squared plus 4, and g of x equals x squared plus 4. Now my reason for this is because I need two of them. If I was working with A, I would write out f of x and g of x. If I was working with B, g of x, f of x. If I was working with C, f of x and f of x. And I'm not. I have g and g. So that's what I'm going to focus on here, is that I have a g of x and a g of x. I need to take this g of x function and I need to plug it into the first g of x. So instead of x, I'm going to put x squared plus 4. When I plug stuff in, I want to put parentheses. And then that whole thing is squared plus 4. Now I'm not going to multiply this out. I don't want to. I need to recognize that this is a polynomial. And since the directions were to find the domain, I need to remember that the domain of all polynomials is negative infinity to infinity. There's no square root. There is no fraction with x in the denominator. Pay attention to those things. All right, I need to pause one more time. All right, so let's pick up with example 5. This is a lot easier. There's not as much work here. It's just it's a single problem, no A, B, C, D. Show that f of g of x, so this is f of g of x, and g of f of x equal x. So I do need to do both of these. Now it's telling me to show that, which means this is going to work. I should get x. So I'm going to start with the f of g of x, which means g of x is going to go into f. So g of x goes into x. So I have 2, and in place of x, I put 1/2 x. Well, 2 times 1/2, the 2's cancel, and I'm left with 1x, which is x. Now I'm going to do the g of f of x. F goes into g. Let me use a different color. F will go into g of x. So I start with the 1/2, and instead of x, I put in 2x. 2's cancel, I'm left with 1x, which is x. So both of them became x. On your quiz, it's not going to say show that they equal x. It's going to ask you if they are inverses of each other based off of you getting x and x, which is what we get into in 5.2. So if you can do this here, you will be able to do the ones that are in 5.2. And lastly, this is probably the most complex problem, but it is one that you do need to be able to do. So find functions g, f, and g. So f of g equals h. Well, this is the same as f of g of x. So if I look back here, f of g of x means g of x goes inside f of x, where you see x. I am breaking this apart. I want to write this into two functions. Since the g of x goes into f, that's the inside function. So here's some quick notes on the inside part. If I have a square root, the inside is the square root. If I have parentheses, the inside is parentheses. If I have a fraction, the part that will be plugged in is the denominator, or wherever the variable is. So when I'm looking at h of x here, what is inside? The part that is inside is the 2x plus 3. So g of x equals 2x plus 3. Well, if I take away that g of x, I take that out, what had to be there for me to put it there? There had to be an x. So that means f of x is the x to the fourth. And you could test it out. If I were to take 2x plus 3 and plug it in there, 2x plus 3 to the fourth. I get the same thing. So that means that I did decompose that function correctly, and I found the two functions that made it. Just in case you need a little extra support with that, here's an example of a square root. I have a square root of 7x plus 1. What is inside the 7x plus 1? That's my g of x. If I take away that 7x plus 1, what had to be there? Just an x. And then I have a couple more here that you guys can look at and see if you can figure out. And if you need help with anything else, make sure you write those notes down and ask me in class. And I will see you tomorrow.